Dear students, welcome to EPG Pathshala. Today in this module, we will be discussing about waste characterization. Now, in our previous module, we have discussed about waste, its definition, what are the different sources from which waste is being generated, and we have also discussed about its composition. Then we have also studied about various factors which are influencing the waste generation. Now, before getting into the module, let us brush up the basic definition. What is waste? Waste is defined as any unwanted material which is of no further use for a primary user. Based on the source of generation, they are categorized into residential waste when they are generated from housing or other colonies. It is characterized as institutional waste when the waste is generated from a university, school, offices, etc. It is the waste which is generated from industries, they are categorized as industrial waste. When all these waste are put together, for example, the waste which is generated from the residential area, the waste which is generated from a commercial area, waste which is generated from a institutional area, and waste which is generated from an industrial area. When all these solid waste are put together, then they become a municipal solid waste. Now, municipal solid waste characterization is very, very important. This will help in defining the management step. For example, this will determine what sort of treatment you have to give for a particular waste. It will also help you to design a landfill. Now, what are the different characteristics of waste? Example, physical characteristics, chemical characteristics, and biological characteristics. The physical characteristics will include its permeability, size, porosity, field capacity, compression, compressibility, etc. Likewise, the chemical characteristics would be ultimate and proximate analysis, and also the heating value of the waste can be determined. Finally, the biological characteristic will help you to determine the nature of biological treatment to be given to the organic fraction of the waste. With this introduction, now let us get into the module. The learning objectives of this module would be to understand the waste characteristics and its importance. You will also understand or study the method by which these waste characterization can be performed. As discussed, waste is described as discarded material that does not have any further use to the primary user. Now, based on its source and nature of origin, it can be categorized as a municipal waste, as hazardous waste, biomedical waste, and radioactive waste, and so on. Different waste streams are composed of different materials, and therefore, they have different health and environmental implications. Municipal solid waste is a waste stream that contains various components like organic waste, plastic waste, metal, paper, cardboard, glass, and other inert materials. As mentioned earlier, they are generated, or they are mixture of waste which is generated from residential, commercial, institutional, and industrial area. Now, waste characterization is a method by which the nature or property of a material which is discarded in a waste stream can be determined. Now, this will help you to find out the appropriate method of treatment or disposal which has to be applied to a particular waste. It will also help in determining the generation of energy from the waste material. Example, based on the heating value of a waste, you can determine whether the fuel can be generated from the specific waste material or not. The physical characterization of municipal solid waste. The physical characteristics of a waste are determined based on the moisture content, particle size, its density, field capacity, porosity, and permeability. The characterization is important and significant because they determine the extent and the rate of waste degradation. Now, let us discuss these parameters one by one. To begin with, moisture content. Moisture content of solid waste, they are generally expressed in terms of weight of moisture per unit weight of wet or dry material. In a wet weight method, the moisture in a waste is expressed as a percentage of the wet weight of the material. In the dry method, it is expressed as a percentage of dry weight of the material. And if you substitute the values, the moisture percentage can be achieved based on the formula provided here. Moisture content in terms of percentage is given by A minus B by A into 100. Now, what is A? A is the initial weight of sample and B is the weight of sample after drying the waste in an oven. Now, it is very essential to determine the moisture content of a waste. This will help us in determining the economic feasibility of waste treatment. Example, when you are applying incineration for a particular waste, it will help us in determining the amount of heat that has to be given to an incinerator. That will help us to know or understand the amount of heat required for evaporating the water or the moisture which is present in the waste. The moisture content also plays an important role in waste processing methods, for example, composting and anaerobic digestion. Too much of water, if it is there in the waste, it will interfere with the composting and the anaerobic digestion process. Hence, it is very essential for us to determine the moisture content before applying any treatment method. The solid waste, in general, if you see, the moisture content present in a particular solid waste will range between 20 to 40%. That can be arid or in a region where there is high precipitation. The next physical characteristic of waste which we will be discussing is density. Now, density of a waste is defined as mass per unit volume. It is expressed in kilogram per meter cube. It is very important for designing a solid waste management system, starting from your waste collection to decide the type of waste collection and transport vehicle. It will also help you to decide the type of storage container required for storing the waste. Also, density is required for designing the landfill structure. Now, the density of waste is affected during the waste management system, that is beginning from your collection to the waste disposal. The density of waste keeps changing significantly. The reason might be due to the decomposition, scavenging, during handling, vibration of vehicles, wetting and drying, and other weather phenomena can also influence the density of waste. So, that is why the density of waste varies significantly from waste collection till disposal. In high income countries, the collected waste is typically of low density because it contains more of recyclables, example like cans, glass, etc. Since the waste is of low density, the compaction vehicles which are used will not provide any considerable benefit because only 75% of volume reduction is achieved. On the other side, if you discuss about the low income countries, there the initial compaction is not favorable because the density of waste is themselves is very high. The compaction vehicles offer little or no advantage and are not cost effective. Next characteristic is particle size and distribution. The recovery of waste material is essential step in a waste management practice. It is important for us to know or have knowledge on the size and distribution of the waste constituents because this knowledge will be useful for us in selecting the waste processing method. For example, when you talk about the size reduction, the nature of shredder or the nature of separator which we have to use. The measurement of particle size and shape of municipal solid waste is challenging because of certain reasons. The complex shape makes the movement of municipal solid waste difficult along the sieve surface. Also, their movement depends upon the forces acting on it. The major means of controlling particle size is generally through shredding. Shredding will increase the homogeneity, it will increase the surface area to volume ratio, it will reduce the potential for preferential liquid flow path through the waste. The particle size will also influence waste packing density. Particle size reduction, that is by shredding, could increase the biogas production through the increased surface area available for degradation of bacteria. On the other side, this can be a disadvantage also. The flip side of this method or the particle size reduction is, smaller the particle, higher will be the packing density, which will decrease the water movement and the bacterial movement and will decrease the accessibility of the substrate to the bacteria. Hence, the particle size is very important and it should always be in line with the treatment method to be adopted. If you are preferring for biodegradation or composting, then the particle size should not be very less. As mentioned, it will decrease the accessibility of the substrate to bacteria, thereby reducing the performance. Next characteristic is field capacity. Field capacity is a critical physical parameter in the municipal solid waste characterization. It is defined as the amount of moisture that can be retained in a waste against the action of gravitational pull. The field capacity will determine the formation of leachate in a landfill. Water in excess of field capacity will always be released, or it will ooze out from the material in the form of leachate. Now, in addition, the release of water is also influenced by other factors. Example, the pressure applied on the waste and also the state of decomposition of the waste. When the waste gets decomposed, obviously the moisture which is retained in the waste material will ooze out as leachate. The field capacity of an uncompacted commingled waste from residential and commercial sources will be in the range of 50 to 60%. Commingled waste is nothing but, again, it is a mixture of waste from different sources. Next characteristic is permeability. Permeability is defined as the hydraulic conductivity of compact waste. Again, it is another important physical property. The movement of a liquid or a gas through the waste will always be determined by permeability. The permeability of waste depends upon various factors of waste like pore size, the surface area and pore size distribution. Permeability will always be inversely related to density, because denser the waste, lesser will be the permeability, and vice versa. The reported permeability of refuse material will be in the range of 10 to the power of -1 to 10 to the power of -5 centimeter per second. Next, porosity. Porosity is also another important physical property like permeability. Now, porosity is defined as the amount of void or void spaces per volume of waste. Higher the porosity, more will be the permeability of the waste. The typical porosity of the waste material will range between 0.4 to 0.67. The porosity will vary depending upon the compaction and the composition of waste. Again, compaction, if the waste is of low density, the compaction again will decrease the porosity of a waste material. So far we have discussed about the physical characteristics. Now we will discuss about the various chemical characteristics of the municipal solid waste. The chemical characteristics will include the proximate analysis, ultimate analysis, heating value and other essential elements which are present in the waste. Now, chemical composition of solid waste is important while evaluating alternative processing and recovery options, especially while looking at waste to energy process where waste is used as a fuel. Then it is important for us to have a basic knowledge about the proximate and the ultimate analysis of a substrate. Now, let us look into the proximate analysis. Proximate analysis includes the analysis of moisture, ash, volatile matter and fixed carbon. If you analyze all these things, then it is called as proximate analysis. Ultimate analysis will be the elemental characterization. For example, if you are determining what is the carbon content, what is the sulfur content, what is the hydrogen content, what is the oxygen content, then that will be the ultimate analysis. The first parameter under proximate analysis would be moisture. We have already discussed moisture, but still again we will just have a look at it. The moisture content of the sample is determined by drying 1 gram of sample at 105 degrees Celsius for 1 hour in a hot air oven. The weight loss will help us in calculating the moisture percentage. Now, moisture percentage will be equal to weight loss by weight of sample into 100. That means, the initial weight of the sample and the final weight. After drying it in oven, the final weight, if you subtract that, then you will get the weight loss, and you divide that by the weight of the sample, that is the solid waste, and you multiply by 100, then you will get the moisture percentage. Next one, volatile matter. The amount of waste. Now, what is volatile matter? The amount of waste which is converted to gas during combustion process or a burning process. I am sure you know what is combustion. Combustion is burning of waste in the presence of oxygen, right. Now, the waste which is converted into gas at the end of or as a result of combustion results in the formation of volatile matter. Volatile matter is the weight loss obtained on heating 1 gram of sample or 1 gram of solid waste at 950 degrees Celsius for 7 minutes in the absence of air. Now, weight loss due to volatile matter will be given by the total weight loss minus moisture. So, the percentage volatile matter can be calculated based on the weight loss due to volatile matter divided by the weight of the solid waste into 100 will give you the volatile matter in percentage. Next is ash. Now, what is ash? The material or the residue which is left out after burning or combustion or incineration, it is called as ash. Now, ash content will be determined by the weight of the residue which is left out at the end of complete combustion of 1 gram of solid waste at 700 to 750 degrees Celsius. The percentage ash can be calculated based on the weight of residue divided by the weight of the solid waste into 100. The last one in the proximate analysis is the fixed carbon. The fixed carbon is a material which is present other than ash that does not volatilize or vaporize when it is heated in the absence of air. This is usually determined by subtracting the sum of the other 3 values which are used in proximate analysis, that is moisture, ash and volatile matter. In weight percent, from 100% you will get the fixed carbon, that is you add moisture, ash and volatile matter and you subtract it from 100%, the value which you get will provide you the fixed carbon value. So, fixed carbon weight percent wet basis is given by 100 minus percentage moisture plus percentage ash and percentage volatile matter. Now, this table will give you an idea of proximate analysis of a typical municipal solid waste. From this table you can see the moisture content will vary from 15 to 40%. The typical value is around 20. The volatile matter varies from 40 to 60 and the typical range would be 53%. The fixed carbon will range between 5 to 12 and the typical value will be 7. The ash value will range between 15 to 30% and the typical value will be around 20%. All these values are provided in percentage. Now, next chemical characteristic is the fusing point of ash. The fusing point of ash is defined as that temperature at which the ash resulting from burning of waste will form a solid by fusion and agglomeration. Now, this solid material which is obtained by fusion and agglomeration is called as a clinker. The fusing temperature for the formation of these clinker range between 1100 to 1200 degrees Celsius. The next characteristic is the ultimate analysis of solid waste. As I told you earlier, the ultimate analysis will give you the elemental composition of waste, whether it's a carbon, sulfur, hydrogen, oxygen, etc. The ultimate analysis of a waste component typically involves the determination of percent carbon, hydrogen, oxygen, nitrogen, sulfur and ash. Due to the concern over the emission of chlorinated compounds. For example, if you have some chlorinated compounds in your waste, then it is essential for us to determine the amount of halogens. Halogens, I am sure you would know what are halogens. They include the chlorine, fluorine, iodine, bromine, etc. The result of the ultimate analysis are always used to characterize the chemical composition of the organic matter present in the municipal solid waste. They are also used to define the proper mixture of waste materials to achieve suitable carbon to nitrogen ratio, which is essential for a biological conversion process. Example, when you talk about the composting and the vermicomposting process, C/N ratio, that is carbon to nitrogen ratio, is very essential. So, in that condition the ultimate analysis will help us. The analysis for solid waste for carbon, hydrogen, nitrogen and sulfur can be done using CHNS analyzer. Now, this will give the elemental composition of the solid waste. The next chemical characteristic of municipal solid waste is the heat content. The calorific value of the waste is given by this heat content. As I told you earlier, this will help us in determining the waste can be used as a fuel, or the energy which is generated from waste can be calculated based on the heating value of a particular waste. The heating value is expressed in terms of calorific value, and calorific value is defined as the amount of heat that is generated from combustion of a unit weight of a substance, and it is expressed as kilocalories per kg. The calorific value is determined experimentally using a bomb calorimeter, for which the heat generated at a constant temperature of 25 degrees Celsius from combustion of a sample is measured. Since the test temperature is below the boiling point of water, the combustion water will remain in the liquid state. During combustion, the gases remain above 100 degrees Celsius, so that the water resulting from the combustion will remain in the vapor state. Now, this table provides you the heating value of few of the solid waste materials. If you see the food waste, the heating value typically ranges from 3500 to 7000 kilojoules per kg. Likewise, the heating value of paper ranges from 11500 to 18500 kilojoules per kg. Cardboard typical heating value is around 16,000 kilojoules per kg, and plastic and textile ranges from 32,500 to 17,500 kilojoules per kg. Likewise, you also have heating value of other materials like rubber, leather, garden trimmings, wood, glass, non-ferrous metals, ferrous metals, dirt, municipal solid waste, etc. Now, if you see the heating value of a mixture of the commingled waste or municipal solid waste, it ranges from 9,500 to 13,000 kilojoules per kg, with a typical value of 10,500 kilojoules per kg. Now, the last characteristic of the chemical characterization of municipal solid waste is essential nutrient and other elements. Where the organic fraction of municipal solid waste is to be used as feedstock for the production of biological conversion products, for example, like preparation of compost, methane, ethanol, it is very essential for us to know what is the essential nutrients and the elements which are present in the waste material. This will help us to provide or to maintain the nutrient balance for proper microbial growth, and it will also help us in assessing the final use of the material made or which is or the end product which is produced at the end of biological conversion. Now, this basically involves the carbohydrate content, the protein content, the fat content, the natural fibers which are present in the waste material. The biological characterization of municipal solid waste. Now, this is the last characterization in the waste characterization. Now, this will help us in determining the organic fraction which is present in a particular waste. Now, as you all know, organic fraction is very important if you are choosing a biological route of degradation or conversion. The biological characterization will help us to choose the biological conversion route. Especially the biological characterization is mostly done for waste which is generated from a food industry or kitchens, canteens, etc. Now, to summarize this module, at the end of this module we have understood what is waste characterization, why it is essential, because waste characterization will help us in choosing the option, the treatment method, and also it will help in designing the landfill structure. So, waste characterization is very, very essential. Now, different characteristics, we have discussed about the physical characteristics, we have discussed about the chemical characteristics, and we have also discussed about the biological characteristics. Under physical characteristics, we have studied about density, porosity, permeability, field capacity, etc. And under chemical characteristics, we have discussed about the ultimate analysis, which includes the elemental composition of waste. We have discussed about the proximate analysis, which is a cumulative analysis, where we have studied about the ash content, fixed carbon, volatile matter, etc. We have also discussed about the heating value. We have also seen what is a typical proximate characteristic of a municipal waste which is generated in India. We have also seen the heating value of different waste materials. We have also studied the biological characteristics where the organic fraction analysis is important for choosing a biological conversion route. Thank you.